Okay, let's talk sample size. You want to estimate the population mean. You haven't yet gotten your sample. You're still in the planning stages trying to decide how big a sample do I need? Well, that's going to depend on two things. Number one, margin of error. How narrow do you want your confidence interval to be? How much do you need to narrow things down? Do you need to estimate the average weight of all the pink elephants just to within plus or minus 1,000 pounds? Or do you need to know it to within 100 pounds or 10 pounds or what? So the margin of error, or the maximum error of the estimate, is you need to know within that many pounds or whatever. The other thing it depends on is the confidence level. Do you need to be 95% sure that the interval you calculate contains the actual population mean? Do you need to be 99% sure? How sure do you need to be? So here is the formula for the sample size to find a confidence interval for the mean. It says n equals, and then in parentheses, z sub alpha over 2 times sigma divided by e, and then the quantity is squared, and then you're supposed to take what that formula gives you and round up to the next whole number. In this formula, the z sub alpha over 2 and the sigma stand for the same thing they've been standing for, and the e stands for the maximum error of the estimate, the margin of error. That's how precise you need your estimate to be. Do you need to be within a certain degree of accuracy? That number is what you put in for E. And then whatever this formula gives you, it's usually not going to come out to be a whole number, but your sample size does need to be a whole number. So the rule is take whatever this formula gives you and round it up to the next whole number. Always round up, because if you round down, you'll get a sample that might not be big enough. It's better to have a sample that's a little bigger than it absolutely needs to be than to have a sample that's too small. So, example. To estimate the average age of the students at a college to within 2 years with confidence level 99%, how large must the sample be if sigma equals 2.3? So if our confidence level is 99%, that means the number we're using for z sub alpha over 2 would be 2.58. Sigma, we're told, is 2.3. E is 2. Notice it said we want to estimate it to within 2 years. So 2 years is our error estimate. And when we put those into the formula, it looks like this. N equals 2.58 times 2.3 over 2, and then the whole thing is squared. Here's what that looks like when I put it into my calculator. And yeah, there isn't a special calculator function that we can use for this. We just put in this formula. So parenthesis 2.58 times 2.3 divided by 2 close parentheses squared. And that showed up as 8.8 something. And remember I said we're supposed to round that up to the next whole number. So rounding 8 point something up gives us 9. So you need 9 students, at least. If you have more than that, that's fine, but you need at least 9 students in your sample. You need to go out and randomly select 9 students and find out how old they are and use that for your sample. Okay, what if you only want the age to within 6 months? You want to know to within 6 months, not to within 2 years, but you want to narrow it down more, to within 6 months, half a year. So Z is still 2.58, sigma is still 2.3, and E is, if you said 6, the formula would think you meant 6 years. We're measuring ages in years, but 6 months would be half a year, 0.5 in years. So the number we're putting in for our maximum error of the estimate, our margin of error, is half a year, 0.5. So there's the formula. When we calculate it, we get, 2.58 times 2.3 divided by 0.5, close parentheses, squared. 140 point something, so rounded up, that's 141. So that's a lot bigger sample. We need 141 students in our sample if we want to narrow it down to within 6 months. And what if you want the age to within 6 months, but you only need a confidence level of 95%? For a 95% confidence level, now z sub alpha over 2 is going to be 1.96. So that's what we put into the formula. So I'm just going to go back and edit that last entry to change the 2.58 to a 1.96, and it shows up as 81.288 something. Now, even though the nearest whole number would be 81, for sample size, we always round up, so I would round that up to 82. We would need a sample with 82 students in it. Let's try another example. It is desired to estimate the mean number of chocolate chips per cookie for a large national brand. How many cookies would have to be sampled to estimate the true mean number of chips per cookie within 2 chips with 98% confidence? Assume that sigma equals 10.1 chips. So the formula we use, n equals z sub alpha over 2 times sigma over e squared. That's what we use to find the sample size, how many would have to be sampled to estimate the true mean, mu. Z sub alpha over 2 for a 98% confidence would be 2.33. That was the number that was on the little table for when you're doing 98%. Sigma is 10.1, and E is 2. So when we put those into our formula, we get n equals 2.33 times 10.1 over 2 squared. And let's see what that turns out to be. Parenthesis, 2.33 times 10.1 divided by 2 squared is 138.45 something. So what would you give as your final answer to this question? 139. You would want 139 cookies in your sample. So that's the end of this section. What's coming up next is what we have to do differently if we don't know sigma. If we don't know the population standard deviation, if we've got a sample, we can calculate the standard deviation of our sample, but that would be S rather than sigma. And in that case, the formula and the numbers we put in are a little bit different, and we're going to be talking about how that works next time.